In this module, we'll create the blueprint for the base block, which is the parent class for all blocks in the game. Our objectives for this module are to create the parent class for all blocks in the game. We'll modify 3D coordinates in local space to account for different points of origin. We'll also modify collision presets, and we'll write a function that correctly calculates where to place a new block when a player clicks on any of the sides of an existing block. To get started, locate the Blueprints folder in the Block Game folder. In the Content browser, right-click and select New Blueprint Class. Select Actor as the parent class. Name the new blueprint BP_BaseBlock. The BaseBlock blueprint will be the parent class for all blocks in the game. As such, we'll add the components and functionality to this actor that all the blocks in the game will need. Open the BP base block. To add a component, click on Default Scene Root and select the Add Component button. Type in Static and then locate Static Mesh. Change the name of this to Block Mesh. In the Details panel, select the SM_block as the static mesh. Scroll down and find the Collision preset and change it from Block All Dynamic to No Collision. The reason for this is we might be using static meshes later that won't be perfect cubes, and we'll have to account for that. So we'll let the static mesh be the visual display of a block, but we'll add a collision to handle the collisions of the block. We also have to account for the fact that the default scene root is in the center of the block, and we want the point of origin of the block to be in its lower left-hand corner over here. So we'll have to change the location in local space of this static mesh. To do that, make sure that the block mesh is selected, go to the transform, location, and change the location to 50 units for each of the 3 axes. You can now deduce that our block is 100 units cubed and that the center of it was at 50 units. By offsetting it 50 units in all 3 axes, we've moved the point of origin of the mesh to the lower left-hand corner when we use it as a blueprint. Let's click on Default Scene Root and add the collision. Come up to Add Component, type in Box, and select Box Collision, and change the name of that to Box Collision. Observe that the box collision also has its point of origin in the center, and we need to position that so that it completely encompasses our cube. First, let's change the size of it. Box collisions use what's called an extent, and an extent specifies the radius of the block. So in the x-axis right now it's set to 32. We're going to change that to 50 for each of the 3 axes. And then we're going to offset the location of the box collision in local space to 50, 50, 50 as well. You can now see that the collision completely encompasses the box. We have to modify the box collisions preset. So go find the collision preset for the box collision and change it from overlap all dynamic to block all dynamic. That way things won't be running through our blocks. All of the blocks in the game will share a variable. So we're going to add a variable by going to the My Blueprint panel, clicking on the Add Variable button. And this is the variable that indicates whether or not a block is breakable. And a good name for that would be isBreakable. And the type should be Boolean, true or false. Click Compile after adding the variable, and then click the checkbox to ensure that the isBreakable variable has a default value of true. The last step to creating the BP base block is to write a function that will calculate where to place a block if the player clicks on any one of the sides of an existing block. Now let's look at the layout of the block. The x-axis proceeds forward like so, y-axis in a positive direction to the right, and z-axis goes upwards in a positive direction. The sides of the block are what's called its normals, and the normals have a direction. The normals for the x-axis are -1 on this side because the x-axis is going in the negative direction. and on the opposite side, it's going to be positive 1. Now, normals are specified with an X, Y, and a Z. So we click here on this block, our normal would be -1 in the X, 0 in the Y, and 0 in the Z. Conversely, on the other side, it would be, if we click here, it would be +1, 0, 0. And if we click on the Y-axis, it will be 0 in the X, 1 in the Y, and 0 in the Z. And if we clicked on the top, it would be 0 in the X, 0 in the Y, and 1 in the Z. We're going to make use of this in just a second. That's why I'm taking the time to explain it. So let's write the function that's going to calculate where to add the next block if somebody clicks on this block. The idea is if we click, say, on this face here, we'll return the coordinates in the world of this location where the next block should be placed. To add a function, click on the Add Function button, and let's change the name of this to getAttachLocation. The getAttachLocation function is going to need 2 parameters to do its work. It'll need the location in the world of where the click occurred, and it will also need the normal of the block that was clicked on. We'll add those by going to the Input section, clicking the New Parameter button, and let's change the parameter name to clickLocation, and that should be a type vector, an X, Y, or Z value. Let's add one more parameter, which will be the normal, or the direction the face that was clicked on is facing, and that will also be a vector. When the getAttachLocation function's done, it will return an output. So we'll add an output parameter, which will be the attach location, and that will also be a vector. In between the start of the function and the end, we'll do the math to figure out what the attach location is. I'm going to walk us through the nodes for this, and I know I promised in the beginning to provide information on why things are done a certain way. We're going to circle back to this function in a later module. So I'm just going to show you the nodes for this so that we can get through this part and get to the part where we start adding blocks, which is really fun. So the math looks like this. We're going to drag off the click location, press plus, and do a vector plus vector, and add the normal to the click location. We're then going to drag off of the sum of those two vectors and type minus and vector minus float and type in 50 here. We're going to subtract 50 from each of the 3 axes in that vector. We're going to take the result of that, drag off of that, and type snap and select vector snapped to grid. And for grid size, type in 100, the size of the grid that we're building our world with. That will be our attach location. Connect the return value of that to the attached location. Again, we'll circle back and explain how this math works in a later module. So that's it for the getAttachLocation function. Click Compile and Save and close the getAttachLocation function. You can close the BP base block. And let's review the objectives for this lesson. In this lesson, we created the parent class for all blocks in the game, the BP base block. We applied 3D coordinates to local space to account for different points of origin. Finally, we wrote a function that correctly calculates where to place a new block when a player clicks on any of the sides of an existing block. I'll see you in the next lesson.